Okay, so here are the two formulas for standard deviation, and at first glance, they might seem a little bit intimidating, but I don't want them to be. One of the things you're going to learn is that if you have a graphing calculator, and it is extremely helpful for our work with standard deviation to have one. If you have one, the calculator will do all the work for you. You don't have to figure anything out on your own. The one point that could be slightly confusing is that there are actually two standard deviation formulas. One is called the sample standard deviation. You can look at that formula on the top, and then on the bottom, you can see the population standard deviation. And what you realize is it's slightly different, okay? One thing that I do want to, one major difference is in the sample, you divide by n-1, and in the population, you divide by n. This is not that big a deal because what you get out of it is each of these formulas are, beforehand you'll be told which one you're looking for. The sample, which we'll typically use, or occasionally the population, but you'll be told what the formula is, and then you can get started on it. The other thing is you will have these formulas to look at. They'll be like on a reference sheet. They'll always be available to you. There's a box inside the box, and it just wants you to realize that the symbol X with a line over the top, we call that X bar. That's the sample mean. That's the one we usually do. And then that's the one we add them all up and divide by how many there are. And then the Greek symbol mu is the population mean. Okay? All right. So, of course, on any test, you're going to have these formulas. That said, we should understand what's going on in the differences. What is going on in these formulas? The first thing is that when you square something and then square root it, it makes the distance from the mean positive. So, for instance, let's say that the mean was 5. Both 3 and 7 are 2 units away, so their deviation is 2. That's how much they're different from the mean. But 1, because subtraction is not commutative, in the formula would be -2, and the other would be +2. But if you square -2, you get 4, then square root it, you get 2. And if you square 2, you get 4, and square root it, you get 2. So by squaring and then square rooting, you basically find that difference from the mean for you, okay? This is why the formula has a square and a square root in it, which if you look up here, you see the square, and then of course the square root. So all that's doing is telling you exactly how far it is away from the mean, and it's getting rid of any negative signs. In each case, one formula is for frequency, and one is not. So in the first case, you would use this first formula well, let me rephrase this. In both sample standard deviation and population standard deviation, you would use the standard deviation formulas to the left before the word or if you only had one of each score. But if you had a frequency table where over an interval, like say for the score 7, you might have 5 7s and 3 6s and 10 5s and 11 8s, then you would want to use the one that has a frequency in it. So anytime you have a frequency table, you want to use the second formula. And it's almost the same thing. By the time we're done, we will go over enough symbols to make that perfectly clear. Okay, the sample standard deviation divides by n-1, and the population divides by n. Just use the correct formula based on whatever the question asks for. It'll say what's the sample standard deviation or what is the population. If it does not say, then assume the sample standard deviation. Okay, don't worry about that line. It'll make more sense in just a couple of minutes. So here's a table that calculates the standard deviation. And I know it looks complicated, but I want you to see that it's really not that complicated. Now, if you have a scientific calculator, your scientific calculator will not do standard deviation. So you're going to have to put all of these values in the columns like this to compute what's going on. So look at the data, left-hand column. You got 9, 9.5, 10, 10.5, 11, 11.5. And then look at the frequency. That means there's 1 9, 2 9.5s, 4 10s, 4 10.5s, and so on. Now, the deviation is the difference. It's the difference between the score, x, and the mean, x bar. Well, we had to figure out the mean, so we added up all of these numbers. 9 plus 2 9.5s plus 4 10s plus 4 10.5s 6 11s and 3 11.5s. Added them all up, divided by 20, and we get 10.525. So that's what the mean is. And then, right, there's what X bar means the mean. We figure it out to be 10.525. And then we have to use it in the formula. Okay, let's go back to the formula again. See how in the formula it says X minus X bar, X minus X bar. So because it says that in the formula, that's what we go back and do here. In each case, we calculate the distance from the mean. So here's the score, 9, minus the average, which is X bar. So I get negative 1.525. Then I do this one, 9.5 minus the mean. Then 10 minus the mean. Every time it's minus the mean. Then 10.5 minus the mean. Then 11 minus the mean. Then 11.5 minus the mean. Now, what we have to remember is in this formula, we square things and then we square root them. So I take each of the values here that I just generated and I square them. And those are all the answers. It's just a matter of hitting buttons on your calculator. Lastly, I want to remember about the frequency. See, there's only one 9. So when I get 2.325625, I get 2.325625. But on the next one, there are two 9.5s. So I have to take the square value and times it by 2. In the next one, I take the square value and I multiply it by 4 because there's 4 in the frequency. That means there's a 10, a 10, a 10, and a 10. So why write the 10 4 times and copy the numbers down 4 times? That would be a pain in the butt. Instead, what we do is we write it once and then just multiply by 4. Likewise for 10.5, I multiply by 4. Notice what happens here. By squaring, I no longer have a negative. Okay? And then same thing here, 0.475. We square it, but we multiply it by 6 because there are 6 that have 11. And then there are 3 11.5s, so I multiply by 3. And that gives me all of these decimals on the right. I add them up, and I get 9.7375. Well, what do I have to do with the 9.7375? I got to use that formula. Notice the frequencies match. Whatever the frequency is here, 124463, is what I multiply by here, 124463. Okay? And then going back to the formula, I take that number, 9.7375, and then I divide it by X minus 1. There were 20 scores before, so I subtract 1 and I get 19. And if I do 9.7375 divided by 19, I get 0.5125. And then that was with the squares, then I have to square root it. And when I square root it, I get 0.715891, rounding it off. That's 0.72. S is the symbol, in this case, for the sample standard deviation. And what that would mean is that the average score is about 0.72 away from the mean. Okay? Sometimes a question likes to know what scores are 1 or 2 or 3 standard deviations above or below the mean. This is actually really important. Like, people say, oh, so-and-so is a genius, or they might insult them and say that they're not very bright. That's actually where they score on an IQ test, which is all standard deviations and means and everything else. So let's try to find a score that's 2 units above the mean. So what we know in this particular problem is that the mean, X bar, is 10.525. So if I want to know what's 2 standard deviations above the mean, I take a standard deviation, which is 0.72, and I add 2 of them. So here's 10.525, and I add 0.72, and I add 0.72 again, and I get 11.965. So the score, 11.965, is 2 standard deviations above the mean. Okay? Now you can try to find the score that's 3 units below the mean. Go ahead, do that. We'll stop and start here. Take a sip of my drink. So, I'm going to get 10.525 minus a 0.72, minus another 0.72, and minus another 0.72. And I get 8.365. So that would be the number that's 3 units below the mean, 3 standard deviations below the mean. If we wanted to, we could represent this as x bar minus 3s. Because if I subtract it 3 times, it's like multiplying it by 3, negative, okay? The one I did before was like x bar plus, because I'm going up, 2s, okay? All right, so on a baseball team, the ages of the players are as follows. Use your calculator or computer to find the mean standard deviation. Then find the value that is 2 standard deviations above the mean. So I'm going to do stop and start, and you can go back and you can copy a table down like we did before a couple of slides ago. You can go back and look at that slide to copy the headings for the table, the columns, or you can try to use your calculator to do it. Either way, I'll show you in a couple of minutes what to do. Stop and start. A couple of minutes, your time. Right away, my time. Okay, so how to find standard deviations on a graphing calculator, which makes life really, really, really easy. Go to the stat button on your calculator. The stat button is right down the middle, third one from the top, okay? Hit stat, and the first thing that'll pop up is edit. Hit enter. When you do that, you're going to see a bunch of lists, and one of them at the top will say L1. Get your cursor all the way up to L1 and hit clear, and then enter. And that'll take any values you have in L1 and it'll eliminate them. Then go and input these values. So put in 21, enter, 21, enter, 22, enter, 23, enter. And you should be making a column in L1 of all of these scores, okay? Once they're all in there, go back and do stat button again, but this time choose calc. And when you hit stat, across the top, it'll say edit, calc, and then something else on the right. Go to calc, and then you'll find one of them, I think it's the first one, will say 1 var stats or 1 variable stats. Hit enter. Then scroll, and then you're going to have to hit enter a couple of times. And then you're going to scroll down and you will see SX, the standard deviation of X, is 6.094533069, which you would then round off to like 6.09 or 6.1. All done. All done. You had nothing else to do but know what buttons to hit. I should also mention that at the bottom where it says n equals 25, there are 25 scores here. So when the n is equal to the same number as the number of scores, you were supposed to put in, there's a really good chance you're doing it right. Okay? What if you don't have a graphing calculator? Well, then you have to calculate the mean, which means you need to add all those numbers up and divide by 25. Then you have to subtract 25 from each score, okay? Or each score from 25. It doesn't matter in the long run. And you can save time by only subtracting once when there are several of each score, and then use a frequency after that. And then, again, multiply by the frequency of each score. That's more than once. Add up the totals you just found, divide by n. Oh, you got to square them, okay? Then multiply by the results by the frequency if you want to. Add up the totals you just found, divide by n minus 1, and then do the square root. You will get the same answer of 6.09. All right? You see how a graphing calculator helps? Graphing calculator is a really, really, really big help when it comes to finding standard deviation. So you can follow the steps we just went over, or you can get yourself a graphing calculator. My advice is to get a graphing calculator because your life will be made so much easier, not only for this particular subject in this course, but for others as well. And I'm also sure that if you take other math courses or even some science classes, the graphing calculator will be a great benefit.